Hey everybody, Mrs. Bixler here, and we are about to start the last chapter of the year. Woo woo! This is chapter 8, which is all about systems of equations. And you're probably like, we've been working so much on equations all year. But this is even more fun because we're going to be graphing equations, which we haven't done really since chapter 6. So get ready to get your mind flowing, those juices flowing, growing, and all that good stuff. So let's do a quick little recap of graphing just to make sure we're all on the same page. So I want you to pause the video and try to graph these two equations. Go! All right, we're back. So this first one is in slope intercept form, and we love this form. This is the first one we learned, very first one we learned. So my y-intercept is negative 1, 2, 3, 4, 5. And then our slope is 2. And remember, it's 2 over 1. So we go up 2 and over 1, up 2, over 1, up 2, over 1. So my line looks something like, oh, wait, so we can go up 2 over 1, but remember, we can also slip and sloop, right? So we can go down 2 into the left one, right? I didn't want to forget to talk about that because remember, you can go up and over, but you can also go down and to the left. So if I connect all of my points here and make myself a nice little line, do you see how my line is going up from left to right? That means it is a positive slope, and this number right here, 2, is positive, so I know I'm in pretty good shape. All right, the second one is a little bit trickier. And this one is what we call general linear form, or sometimes like standard form. And we use the cover-up method here. And remember, the cover-up method tells us the x-intercept is when y equals 0. So 5 times 0 is 0. So I can just cover up that 5y term and say 2x equals 20. So if 2x equals 20, I know that x equals 10. And then I can do the same thing for my y-intercept. So 5y equals 20. So if 5y equals 20, that means y equals 1, 2, 3, 4. Amazing. So I've got my 2 points. And remember, 2 points determine the line, but there are an infinite number of points that are on a line. So all I need is 2. I can draw a nice little line and connect them. Ba-ba-da-ba, and you're done. You feel good about that? That's fantastic. You're feeling like, maybe go back and double check your chapter 6 notes. We're going to do more graphing practice today, and you'll do it in the worksheet too, but I just want to make sure you feel good about that. All right, so now into the crux of the lesson. So if you remember in chapter 6, we talked a lot about Rosie's, which is that self-serve frozen yogurt place. And at Rosie's, you pay 3 cents for every ounce that you get in your cup, but you also have to pay for your cup. So for some weird reason, if you want to walk in and just buy a cup and not put frozen yogurt in it, you have to pay 2 cents. So if I walk into Rosie's, what I am expecting to pay is determined by this equation that we see right here. So let's break down this equation into parts that we understand. So like I just told you, this 2, which is also known as our y-intercept, this is the price of our cup. And then, sorry for the pen delay. And then this 3 is what we said before. So it's going to be the price per ounce. So it's 3 cents for every ounce that I get. And then remember, and that 3, remember, is our slope. And remember how we talked about x and y? X and y stand for every coordinate point that fall along your line. Remember, there are an infinite number of coordinate points that fall along a line. And so those coordinate points are represented by x comma y. And in this situation, in this scenario, our x stands for the number of ounces that we put into our cup. And Y stands for the total amount of money that we have spent at Rosie's. So we've got Rosie's down pat. We feel good. But then, bum, 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 Pinkberry's in the game too. So RIP Pinkberry, we miss you on Greenwich Avenue. But Pinkberry's in the game too, and they want to also do self-serve frozen yogurt. And they are charging by this equation. So y equals 2x plus 4 is representative of the amount of money that you would pay at Pinkberry. So if we break this down, our cup is going to be more expensive at Pinkberry than it is at Rosie's because it's 4 cents for a cup as opposed to 2 cents at Rosie's. But if you look at Pinkberry, their yogurt itself is actually cheaper. It's only 2 cents per ounce at Pinkberry, while it's 3 cents per ounce at Rosie's. So, interesting. If I'm going to compare these two, I'm going to throw them onto a graph just to kind of understand it a little bit more. So let's go ahead and graph these guys. So kind of do it in your head while you watch me just to make sure you're feeling comfortable. So let's do Rosie's first. So our y-intercept, or the price of our cup, is 2. And so then our slope is going to be 3 over 1. So I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. Cool. So there's my line that represents Rosie's, and I can go in this direction too. And then let's also look at Pinkberry here. So Pinkberry, my y-intercept is 4. So I'm up 1, 2, 3, 4. And then my slope is 2 over 1. So I'm going to go up 2 over 1, up 2, over 1, up 2 over 1. Interesting. So what do you notice here about what happens? And my line for Rosie's is not perfect. So I can continue Rosie's a little bit more just to make it look better. So my Rosie's slope is 3 over 1. So I would go 1, 2, 3 over 1 here. And then my Pinkberry is up 2 over 1. So Pinkberry looks like this, while Rosie's looks like this. So what do you notice here about these two lines? They cross, awesome. But what also happens? When they cross, they flip. So look what happens up until this significant point here. And this is the coordinate point 2, 8. Which is more expensive? Well, Pinkberry, right? The purple one is up on top, up until 2. And then what happens after 2 is Rosie's gets more expensive. So this coordinate point, 2, 8, is significant because if we go back to what we said on that first slide, or sorry, the previous slide, is we know that 2 stands for the number of ounces in our cup, while 8 stands for the amount of money that we pay. So if we get 2 ounces of yogurt in our cup at either store, we're going to pay 8 cents. That's what that coordinate point means. And then after 2 ounces, Rosie's is more expensive. Before 2 ounces, Pinkberry's more expensive. But at that sort of turning point, that's when they both are the same cost for the same amount of yogurt. Great. All right. So what we have just talked about here, these two equations, this is called a system of equations. And if I had to define a system of equations is just more than one equation. So you can deal with 2 equations or 3 equations or 4 equations. We're just going to be dealing with 2 equations, but maybe if we get excited, we'll do a 3 by 3. So this is a system of equations, and the solution to a system of equations is what we just found on that previous slide. That 2, 8, that would be considered the solution to our system. So the solution to a system of equations is simply where those 2 lines cross. That's it. So there are 3 ways that you can solve a system of equations. There are actually more than 3, but we're going to talk about 3 of them. And the one we're going to talk about today is graphing. So graphing is one method of how to solve a system of equations. We're going to talk about substitution and we're going to talk about elimination later. But let's knock out graphing today. So let's look at this system. And I want you to pause the video and try and graph this on your own. Do it! All right, we're back. So I'm going to graph the red one first. So my y-intercept is -1, and my slope is up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So I rose and I ran, and then I'm going to slip and sloop. So I'm going to go down 1, 2, 3, 4 over 1. And I'm just going to do that so that I can have a little bit more of a sense and a better sense of what this guy looks like. And again, if you use the line tool or if you're writing this by hand, get a straight edge or something, you can do better than I'm doing. All right, and now let's try the blue one. So my y-intercept is 1, and then I'm going to go up 1, 2, 3 over 1, up 1, 2, 3, over 1, up 1, 2, 3 over 1. Interesting. Look at our nice little lines. So, do you have a solution to the system of equations? You do. Your solution is this coordinate point. So the coordinate point 2, comma 7 is the solution to this system. That's what we call the solution to a system of equations. It's where the two lines intersect. So let's try this one. What? This looks crazy. What is f of x? What's g of x? Ah, remember, function notation, do not get scared. This f of x and g of x, those are the same thing as y. We're just saying that they are two different functions. So you can go ahead and graph these ones just the way we did before. So my y-intercept is 1. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, yada, 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 yada. So I'm going to go down to an over 1 just to give myself a little bit more space here. All right. And then I'm going to try my g of x. So my y-intercept is 1, 2, 3, 4, 5, 6. And then now here's a negative slope. So I'm going to go down 1 over 2. What? Down 1 over 2. Look, I don't have to go much further because I see that they already cross right there. What is this coordinate point? Oh my God, again, we are at 2, comma, I'm trying to get it to be green. Sorry, everybody. So we are at 2, comma, 1, 2, 3, 4, 5. So 2, comma, 5 would be the solution to this system. All right. Pause the video and try this guy on your own. All right, so this is a cover-up method 1. So let's try this. So this one is a little messy, right? And what I would say here is I would say that you can rewrite this into y equals mx plus b form. Because if you did the cover-up method here, you'd wind up dividing 8 by 6. Ugh. So instead, rewrite this guy and get it to be y equals 6x. Oh my gosh, sorry for the delay. 6x minus 8. So 6x minus 8. So let's go down. So 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go up 1, 2, 3, 4, 5, 6 over 1. Boom. 1, 2, 3, 4, 5, 6 over 1. All right. Got it. Boom. Boom. And then this one is kind of nice cover-up method. So my x-intercept is going to be 1, 2, 3, 4, 5. And my y-intercept is going to be 2. Interesting. Shoot, this one's kind of tricky and annoying. So here is, and it's not due to my like wibbly wobbly lines. Here is something that's important. It is not always going to be little butterflies and rainbows and daisies. There are going to be times where our two lines intersect and it is not at a really nice point. So do you see how it's a little hard to see exactly where these lines cross? That's why we have those two other methods. That's why we have substitution and elimination, because those help us with a little bit messier systems. So when we are dealing with graphing, though, you will always be given a system where the two lines cross at obvious places. And that's done on purpose. So go ahead, tackle the worksheet. You're going to crush it. And I'll talk to you all soon. Thanks.